Modern-day networking, an exhaustive guide. Modern-day networking refers to the advanced communication systems that connect computers, devices, and systems, enabling the transfer and sharing of data across various platforms and distances. With the rapid evolution of technology, networking has become more sophisticated, secure, and integral to almost every aspect of our digital lives. Below, I'll break down the key concepts, technologies, and components associated with modern networking in a detailed yet simple manner. 1. Basics of networking. A. Network types. LAN, local area network, a network that connects computers within a limited area like a building or campus. WAN, wide area network, a network that covers a broad area such as cities, states, or even countries. MAN, metropolitan area network, a network that spans a city or a large campus. PAN, personal area network, a small network for personal devices like smartphones, tablets, and laptops. B. Networking components, routers, devices that forward data packets between computer networks. Switches, network devices that connect multiple devices within a LAN directing data to its intended destination. Firewalls, security systems that monitor and control incoming and outgoing network traffic based on predetermined security rules. Access points, hardware devices that allow wireless devices to connect to a network. 2. Modern networking technologies. A. Ethernet, wired networking. Ethernet is the most common LAN technology, using cables to connect devices to the network. It offers reliable and high-speed connections. B. Wi-Fi, wireless networking. Wi-Fi is a technology that allows devices to connect to the internet or communicate wirelessly within a certain range. Modern Wi-Fi standards, like Wi-Fi 6, provide faster speeds and better performance in crowded environments. C. VPN, virtual private network. Secure remote access. VPNs enable secure connections over the internet by encrypting data and masking the user's IP address. This is essential for remote work and protecting privacy. D. SDN, software-defined networking. Network virtualization. SDN allows network administrators to manage and control network behavior dynamically through software, making networks more flexible and efficient. E. NFV, network functions virtualization. Network service virtualization. NFV decouples network services like firewalls, load balancers, and routers from the underlying hardware, enabling them to run on virtual machines or containers. F. Cloud networking. Networking in the cloud. Cloud networking involves the use of cloud-based services and infrastructure to manage and deliver network resources. This includes using platforms like AWS, Azure, or Google Cloud to host and manage network functions. IoT, Internet of Things. Connecting smart devices. IoT networking involves connecting everyday objects to the internet, allowing them to send and receive data. This includes smart home devices, industrial sensors, and connected cars. Number 3. Network security. Data protection. Encryption is the process of converting data into a code to prevent unauthorized access. It's essential for protecting sensitive information, especially in online transactions and communications. B. Firewalls and intrusion detection systems, threat prevention. Firewalls and IDS are critical components of network security, monitoring traffic for suspicious activity and blocking potential threats. C. Zero trust architecture. Trust no one. Zero trust is a security concept that assumes that threats could be inside or outside the network. It requires strict verification for every person or device trying to access the network. D. Multi-factor authentication, MFA. Enhanced security. MFA adds an extra layer of security by requiring users to provide 2 or more verification factors to gain access to a resource. E. Secure Access Service Edge, SASE. Converged security and networking. SASE is an architecture that combines network security services with wide area network WAN capabilities to support the dynamic secure access needs of organizations. Time for advanced networking concepts. A. Network topologies. Network layouts. Topology refers to the physical or logical arrangement of a network. Common topologies include star, mesh, and hybrid. Modern networks often use hybrid topologies to balance performance and redundancy. To B. IPv6, next generation IP addressing. IPv6 is the latest version of the Internet Protocol, providing a larger address space and improved security features compared to its predecessor, IPv4. C. MPLS, multi-protocol label switching. Efficient data routing. MPLS is a technique for speeding up network traffic flow by directing data based on short path labels rather than long network addresses. D. Network automation. Automated network management. Automation in networking involves using software to manage and configure network devices, reducing the need for manual intervention. This is crucial for large-scale networks. E. Edge computing. Decentralized computing. Edge computing involves processing data closer to where it is generated, at the edge of the network, reducing latency and bandwidth usage. It's important for IoT and real-time applications. F. 5G networking. Next generation wireless. 5G is the latest generation of mobile networks, offering faster speeds, lower latency, and support for a massive number of connected devices. 5. Networking protocols. A. TCP/IP, Transmission Control Protocol, Internet Protocol, foundation of the Internet. TCP/IP is the fundamental protocol suite for modern networks, governing how data is transmitted and received over the Internet. B. HTTP/HTTP, web communication. HTTP Hypertext Transfer Protocol is used for transferring web pages. HTTPS is the secure version, encrypting data to protect against eavesdropping. C. DNS, Domain Name System, Internet Address Book. DNS translates human-readable domain names like www.example.com into IP addresses that computers use to identify each other on the network. D. BGP, Border Gateway Protocol. Routing between networks. BGP is a protocol used to exchange routing information between different networks on the internet. It's crucial for ensuring data finds the best path across complex global networks. 6. Trends and future of networking. A. Artificial intelligence in networking. AI-driven networks. AI is increasingly being used in networking to optimize traffic, predict and prevent outages, and automate complex tasks like threat detection. Network slicing. Customized network services. Network slicing allows operators to create multiple virtual networks on a shared physical infrastructure. Each slice can be tailored to meet specific requirements, such as low latency or high bandwidth. C. Quantum networking. Next level security and speed. Quantum networking, though still in its early stages, promises to revolutionize data transmission with unbreakable encryption and faster than light communication using quantum entanglement. D. Green networking. Sustainable networking. Green networking involves designing networks with energy efficiency in mind, reducing power consumption, and minimizing the environmental impact of network infrastructure. Bar 7. Challenges in modern networking. A. Security threats. Cyber attacks. With more devices and data online, networks are increasingly vulnerable to cyber threats like ransomware, phishing, and distributed denial of service, DDoS attacks. B. Scalability. Growing networks. As organizations grow, their networks must scale to accommodate more users, devices, and data, which can be challenging without the right infrastructure. C. Complexity. Managing modern networks. Modern networks are complex, with multiple technologies, devices, and protocols to manage. This requires skilled professionals and advanced tools for efficient management. D. Interoperability. Working together. Ensuring that different network devices and systems can work together seamlessly is a major challenge, especially in environments with equipment from multiple vendors. Conclusion. Modern-day networking is a vast and dynamic field that plays a crucial role in the functioning of our digital world. It encompasses a wide range of technologies, from the foundational protocols that govern data transmission to the advanced security measures that protect our information. Understanding these concepts is essential for anyone working in or interacting with today's connected environments. As technology continues to evolve, networking will likely become even more sophisticated with new challenges and opportunities on the horizon.